Hi, everyone. Today, we're going to talk about optimizing smarter, not harder, with Unity performance tools. If you were looking for a talk about optimizing harder and not smarter, maybe I'll pitch that one next year. We'll see how this goes. But hopefully, we're going to cover a bunch of stuff. We'll learn a few things along the way. So my name is Peter Hall. I manage the profiling and optimization team at Unity. We look after a few of the profiling tools that are part of Unity. We also do work on optimizing the editor, and we do stuff measuring performance of the editor, various different things to do with performance, basically. And the small tip I kind of take out of this before I even get onto the first real content slide is we're doing this stuff where we measure performance of the editor, and then we optimize things and we measure again. So first, performance and optimization tip, measure, optimize, measure, and then you get good results. So on to the profiling tools themselves. There's quite a few. There are three that I'm going to cover here today: Project Auditor, the Profiler, and Memory Profiler. But we will touch on some other stuff in here as well. And obviously, I figure any good talk should have some type of theme to it. And I sat down and scratched my head for a bit, and I had to think, what can I use as a theme? And I figure these tools, they're the recipe for success for you. So we're going to go with a kind of a cooking theme. And I've taken the liberty of preparing a menu for us today. So we have here, for starters, Project Auditor. Main course will be Unity Profiler, and then for dessert, some Memory Profiler. And after looking at this, I did think maybe these don't sound as tasty as I thought they would when I first came up with the cooking idea, but I'm sticking with it now. So that's how it's going to be. Skipping back for a second, I know I've said here I'm a manager on that team. Do you really want a manager to talk through profiling and optimization when it's presented in the form of a menu? I don't think you do. I think clearly the best person to talk through a menu would be a chef. So if you can spare a moment. I have the problem now where I have to do up a lot of little fiddly buttons quickly with an audience watching me, but we'll get there. One more. And I have my wooden spoon. And I have my hat. So, here we go. I've also adjusted this slide a little bit. And I did an internal talk at Unity on a different topic, and I've spent £10 on this, €10. I'm getting my value for money, so I'm using it here too. It's kind of my terrible secret identity. Time for the first course, Project Auditor. Project Auditor is a tool that was created by performance consultants at Unity. So the keynote yesterday, there was discussion about Unity Studios and performance validation or product validation. And teams involved with that regularly work with customer projects. And they need to get up to speed quickly on those projects. So they want to be able to open the project up, look and see if there are common issues in there, see them listed, understand what they are and how they might affect the problems that a customer's having, and then get stuck in as quickly as possible. There are a lot of different common issues that they were seeing in every project they were looking at, and they were like, let's put rules in, find those things, and show them in this tool. So that's what Project Auditor is for. It exists as a package in versions of Unity up to 6.3, and we support it in all currently supported versions of Unity. From 6.3 onwards, it's going to be built in, so it'll just be there. You won't have to install the package. It'll be a module. Now, I've come a little unstuck again, trying to work out how this fits in with cooking. So I have this quote. Static analysis is the cookbook for your code. Structure, order, and safeguards. Follow this, your project will not burn in production. And that quote is from the well-known anonymous LLM. So I'm imagining myself coming back to this at the end of the project and saying, my project did burn in production, and then getting back the response going, you're absolutely right. I'm very sorry about that. What issues does it find? So it processes your code, your assets, import settings, and a few other things. How do I use it? I'm going to attempt to do a live demo here, and what could possibly go wrong with a live demo? So for Unity prior to 6.4, you will need to get the package. I'll switch over to my laptop. Here we go. Yeah, there we go, it is there. And you'll need to get the package, install the package in Package Manager. If you're prior to 6.1, so 6.0 or 2022.3, you need to install it by name, which you can find in the package instructions documentation. Otherwise, it should be there in the Package Manager. So after that, to open this up, find my mouse cursor, we come to Analysis window, and then down here is Project Auditor. That will bring you to a screen that looks something like this. There are some new options on this particular screen here, but if they're not there on the version you're using, you can find them in the Preferences window. Project Auditor has things where you can choose what version or what issues you want to see. So if you're interested in asset issues, you say, no, I want to see assets. Typically, you probably want to put it in all. I'm just going to leave it in that for now. But you can also switch between different platforms you have installed. This does sometimes give you specific asset rules based on the platforms you're on. So we have stuff that looks for, say, sound, memory size, and things on mobile devices that we might not recommend on a PC. But it also will compile the code with that defined. So if you have bits of code you want to analyze that are on one platform and not another, you need to make sure you're looking at the right setting there. You can also analyze in the compilation mode setting here the different settings for the defines for editor versus player. But typically, probably want the player. So set that all here, click Start Analysis, and we wait for it to get on. I'll switch back to my slides while my laptop continues doing that analysis. So how does the code analysis work? Project Auditor will compile your assemblies, and it will analyze the IL that's produced, the intermediate language. And it'll look through that for issues. Most of the code issues tend to fall into one of three areas. They're typically places where managed memory is allocated, places where something like link or reflection is being used, or something like debug logging code, things like that, so things that are raised in there. Project Auditor will try and guess what's a sensible severity for that issue, and it effectively has a kind of preset thing for the rule, but then if it sees this is happening in update code or regularly called code, it'll bump the severity to make it a bit obvious that that thing is more important, and you should investigate it. So every option, or everything that is found in Project Auditor will have some recommendations alongside it. So we come into the code section here to have a look at some of the code things that we found in this project and pick something out of the table. See down here we have details and recommendation sections. So we will actually give you details of what is occurring and a recommendation for what you should do. Where we can, we also should have links to the documentation about what you should go and read up on to understand the issue better. All the issues that you find in Project Auditor, you can choose to ignore that one. Maybe it's something you don't care about in your project. I've looked at it, it's not important. If you want to bring it back, you then show ignored issues and just display it again. So that will bring things that are in the ignored section back. For asset issues, we come down here. The workflow is pretty similar. So we have a table that lists the issues. You see the thing. You've got details and recommendations over on the side. With most of the tables in Project Auditor, you can filter them. So we can filter this to say whether we're interested in just particular assemblies or everything. If you really want to, you can come into here and check a box to say, I want to see package content. Let's tick that one while I'm here. And that will show you all the issues that are in your package code as well as in your project code. Coming down to the rest of the things in the assets table, we have tables for different type of assets as well. So if you're wanting to look at a glance, see all your textures, and you can then go and investigate what their settings are, this can be useful if you think, I have a rule where all our projects' textures must be smaller than this or compressed like that. It's a quick way to just look at a glance and see whether or not there's anything that's missing from that. We have things in sprite atlases where you can go and investigate what's going on with those. Meshes, audio clips, so on for the different types of assets. Coming on down to shaders. So for the shaders table, this will show you the number of variants you have on shaders, and you have to do a build to do this. It looks at how many shader variants were built for each shader. I haven't done one here, so we don't have that column filled out properly, but if you go and do a build and then come back, you will see that column's filled out for you. And we have a second page here, which is a slightly complicated page to use. There's a bunch of text which describes what you need to do it, and I won't run through all of it. But the gist of this is that you can tick this box, make a build, you run that build, and you get the player log. If you bring the player log black into Project Auditor here, then Project Auditor will show you which shader variants were used during that run of the game in the same kind of table that you see the build ones. So that gives you a starting point if you're looking to strip shaders out or understand why you've got a lot more shaders in the build than are being used. That can show you which ones you're actually using and which ones you're not. You can see some information about shader compiler messages, list of materials, just like the other kind of asset tables. And then we come down to project settings. So for project settings, we're looking for places where we know that there might be a way that you can improve your project's performance by changing something in the settings. For example, here we have the graphics jobs being disabled. Now, typically, there's a reason that the settings is defaulted to be something. And so the recommendation with a lot of these is that you go and investigate, probably try the setting and see whether it's better or worse for your project. Often we try and highlight what that reason might be so you know what to look for. But some of these things are just like maybe you want to come in here and you want to go and clear up your physics collision layers. You can see a list of packages in the project, although I haven't filled that one out because I didn't select one of the options. And then we have a table that shows you things about your build size, which textures and things are using most space up in your build. And another table which shows you the build steps. So if I do a build and come back to this, I will see a list of the different steps in my build and how long each one of those took. So coming back over here, my tips and tricks for using Project Auditor. I have a few. I've already mentioned that most of the issues have some sort of link to documentation and some text about them, and those things are worth reading if you're not sure what's going on. If you're happy using Assistant in Unity or you're happy using some other AI tooling, I found those can be a great place to go and ask about stuff that you don't know about either. Just by copying some of the stuff that's in the table and pasting it in, you can then say, do I need to fix this? And tools will actually go and make a reasonable recommendation. Most of the time when I've used it, it's picked what I would have chosen to do for the issue or given me a clue about what I might be missing out on if I don't do that. And a lot of things in Project Auditor highlight potential issues. They could be an issue for some projects, but not for yours. For example, we have a lot of warnings in there about audio compression settings. We have stuff about sounds that are stereo. And typically what that's trying to do is tell you, you have a sound which is stereo in your project, but we think you're playing it in a way where you only need a mono sound and it's being panned. However, the rules can't detect all of the ways that you're using the assets. So there's a recommendation to go and look and check. It's not a, you must do this. The other thing I'd recommend doing with Project Auditor here is to cross-reference the code issues with things that you see in profiling tools. So if you see a marker is expensive in the profiler, go and check in Project Auditor and see if there are things in that function that it recommends you should fix, because it's probably got some managed memory or maybe use for a call that you were you're calling into link or something that it can pick up for you. There are a few things that Project Auditor can do that I kind of skipped by. I'm going to come back to one of them now, and we're going to do a walkthrough of this. So lots of you might be familiar with domain reload and disabling this on the way into play mode, but I know a lot of people who don't do it, so I want to kind of drill into this and why it can be an issue, what you gain out of changing this setting. So if you think of the domain as being like a .NET box that contains all of your C# code, your assemblies, contains all of your data from those as well. So when you're allocating memory and you have stuff serialized in, it's all in this box. And this will include all of the editor and our package and engine code as well. It's all in there. And every time you change a script, what we do is to throw the box out and reload it from scratch. And I'm going to come back to my cooking again. I'm going to say this is an oven. And these are the food in the oven. And the process of reloading the domain will involve taking the food out of the oven or serializing your data into a buffer off to one side, I'm not quite sure how this works. I think we're destroying the oven at this point, and then getting some people in to fit a new oven while we were cooking, and deserializing the state from the buffer back in. So we're bringing all your data back into the buffer, and then we're going to perform the various setup calls and things that you have normally when your objects are initialized to make sure that everything is back in the state it should be. Why am I talking about this bit? Well, the work is not free. It's a bit of a small profile and capture here, but this is a medium-sized project. It spent about 7 seconds on this frame, and this is the frame where you were entering play mode in the editor. So this is a project where somebody's click play, wait for 7 seconds. And taking a bunch of other projects, this is from when we initially added this option about 5 years ago. I think it'll be worse in some big projects now. But you can see the blue bars here are what you get with this setting turned off when you enter play mode. And the orange bar are what you can get to with this Project Auditor analysis. So even with an empty project, it might be 2.5 seconds or so entering play mode. Change this option, we can get down to nothing, pretty much. But the option comes with a catch, or it will be on by default. Why don't we just set the option always? You've got to make some changes to your project and your code in order to actually be able to turn this on and have your code behave in the same way afterwards. Nearly all of the changes you have to make here are around static things, so static variables. Because when we throw away the domain and bring in a new one, all the static variables in the code are reset to their initial values. But when we turn this option off, that will not happen anymore. You need to have some code in your project that resets all of your static variables back to their initial value, or you might introduce bugs, or it might behave differently. I'm going to do a live demo of this again, so we will come back over here. I'm going to switch back to my laptop. So I have been using here our Dragon Crashers sample project, and as it turns out, Dragon Crashers actually doesn't have lots of static variables in it, so I've introduced one here and made a mess just to demo this to you guys. Let me bring my Project Auditor window back up. So Project Auditor here is raising one issue, which is in this Screen Fader Manager C# file. And if I go and look at that file on line 28, I can see there's a static variable. If I come into Unity, come down to Project Settings, in the Editor section up here, I have Reload and Domain and Scene set. And if I come and show you, when I enter play mode, we have to wait here. It's a couple of seconds time. It comes in. And just to show that that wasn't a fluke, or make sure we get rid of any first time slowdown, there you go. So there's a bit of a delay every time we go into play mode at the moment. And we can just come in here. We could just change that to be reload scene only. Now, why am I recommending we do reload scene only here? There are some other bugs which Project Auditor does not detect if you switch straight over to doing neither of these. So rather than suggesting you try it and might hit bugs, I'm saying let's go for the one where we're just doing the scene. That gets rid of most of the cost. So we do that. And then if we click here, we can see this is almost instant. However, we've introduced a bug. I happen to know where the bug is. So if we click tap to play here, it's going to fade to black, and then we're going to see the start of the next scene in the game. But that static variable that I've messed with will mean that if we come in here and tap to play again, we skipped the fade to black. So this is something where you can introduce issues that are quite difficult to spot in your project, depending on exactly what static variable it was. I happen to know that one's there. But to fix this, all we need to do is to come into Project Auditor. It tells us the exact line and class that the variable exists in. And then there's instructions here that tell us the script contains static fields, but does not contain a method with this attribute, runtime initialize onload method. And that's how we know whether or not you're clearing the variables. If you put that on a function, it will be called at the right point, and then you can reset all your statics. As luck would have it here, I have one I've made earlier. So we can just uncomment this block of code. All it's doing is setting that static variable back to be what it was at startup. Save my file and come back into Unity. We do have to do a domain reload still whenever you change scripts, because we're compiling the script and loading the information in. So the enter play mode optimization here is helpful, doesn't get rid of domain reloads completely. But now if we come in, we click play, we can tap to play and we get the fade to black. And then we can do it again, and we see the same thing. So we fixed the issue. In theory, all you need to do for your project is run through this list of issues in the table, find the classes where you need to set this, and then you can change that option over, and you should get considerably faster interplay mode time. So move on at this point. Stop looking at Project Auditor, and we're going to look at the profiler. So I guess that's course 2, main course. If you're not familiar with the profiler and how to profile your game, I gave a talk at Unite last year about this, and rather than go over the exact same stuff again, I'd recommend going to look at that or one of the other resources on YouTube, or we have ebooks about this as well. They're all great resources to learn about doing that. So what I'm going to talk about here is stuff that's changed since the last time I did this, and stuff that might help you that wasn't there before. Now, one thing that when I went to do this, I obviously had to go and check my QR code worked. And so I went to visit my video last year to see what was in there. And I happened to notice there was a comment at the bottom from somebody. I deliberately added some slow code to the project because I want to be able to show people how to optimize. I see this comment, and it says, Pathfinding Manager, bro is cooked. And I thought, this is perfect. They've nearly hit my cooking metaphor on the head. I haven't quite worked out. I mean, I'm supposed to be cooking the projects, I think, and not me, but I'm going to put it in the talk anyway. And just in case you're very cynical, this was added 8 months ago. I was not planning this 8 months ago. That's not me. Back to the profiler. What's new in the profiler since I talked about it last time? The presentation last time, I went through a bunch of different workflows that you can use to optimize your project. And one of the main things that we wanted to try and do was make it easier to follow those workflows by default, because it involves using multiple tools sometimes and multiple parts of the tools. I started off by looking at the highlights module, which gives you a split between whether you're CPU bound or GPU bound, so you know where to start investigating. And from Unity 6.3, we've now got help with the next step of the investigation from there. We'll do a proper demo of this in a minute, but the Capture Highlights module is at the top of the screen with the red and yellow strips, and when you select it, you get a summary of the capture at the bottom of the screen. And the summary of the capture at the bottom of the screen will show you things like the highest markers in the longest frame. So if you've got spikes, that should call out the places which are causing those spikes. But then we also show you the top markers across the whole capture. So if it's something where everything is expensive, that will bring those things out and show you what those things are. At the bottom, we have stuff about GC allocations as well. And that can be useful, particularly across the long range, because then you can go, where are the biggest source of my GC allocations in this project at the moment? One of the other things that I mentioned earlier was our recommendation that you do a profile, you do an optimization, and then you profile again. And it was all too easy to forget to save your profile capture or lose it because it was just a loose file. So one of the things we introduced now is a capture list, which sits down the side of the profiler. As you do stuff in the profiler, all your captures get added in here. You get a little screenshot of the capture, and you get a little sample of the highlights bar. So hopefully that's enough between those to remember this is the capture that I want to compare to and work from there. Another quality of life change, something that we've noticed we were doing a lot. Particularly if you're profiling in the editor, the profiler data can go past pretty quickly in the profiler window because frames are rendered very fast, and we only support it up to 2,000 frames. But there is a setting in the preferences for the profiler to change this, and we've bumped that up to the maximum value is 4,000. We really want to get to a place where we can actually just have you doing long captures of the project and bring that in, but it's going to be a while we get to that. So as a kind of stopgap, we've allowed you to increase that a bit more. The reason this is a preference, though, is in case you want to actually zoom back in to see the data better, because our chart view at the top doesn't support zoom, and therefore this lets you kind of just see the 600 frames spread across the window rather than the 4,000. It makes it a little bit easier to see details. So let's try that out. come back over here and find my profiler window. I think I have hidden it here. Here we go. So over on the left here, we have the capture list, which I mentioned, and I can see I have a capture with a spike here, so I'm going to go load that capture, and here we go, a capture with that spike in it. And if I interact with the highlights bar up here, we get the summary view down the bottom here. And you can use this drop down over on the side here to change whether you want to view data about the entire capture. So this is showing me what the top markers were on the longest frame, what the top markers were overall, and where my GC allocations were coming from the whole thing. However, I can also drag up here and select a range, and that will show me the markers for that range, or I can, a bit fiddly trying to find the exact frame, but I can pick one frame and I will get information just about that single frame out here. Now, investigating over here, if I go to this range, I can see that the main marker I have here is Create GPU Program. These little buttons down the side of all of these are frame numbers. So, you know, if I've done this for the whole capture, I can see information about where a particular marker is slow. So the preload manager stop was slow here. These are the markers we're on frame 381. If I click on the button, then we go straight to seeing that frame in the summary view. And then you can actually look here in the table, or the table over the side, we've got buttons to view, which will take you into the hierarchy. From there, I can go and view it in the timeline. I can focus on that thing. So it's a process of trying to walk you through finding those long markers and places that should be, you should go and investigate sooner. In there. See if there's anything else I've missed off on that list. I think we're probably good here. Yeah. So, finally, time for dessert. We've got Memory Profiler for dessert. What have we changed in the Memory Profiler? The main focus that we've had this year with Memory Profiler has been around what's called unknown memory in the Memory Profiler. And we're trying to make improvements in that area. I know that it can be really frustrating if you have a capture, you're 200 megabytes or a tiny bit over your budget, and you see you've got that same amount of unknown memory in the capture, and you're like, if I could just get rid of that, I would be within budget. So we know that it's really difficult if all we tell you is this memory is unknown. What is it that we've done? Well, firstly, and this is not the exciting part, we've renamed it. This bit is really boring, but it's kind of key because it tells you what that memory actually is. If we saw something that was unknown, that means it's native memory we allocate at Unity, and we've not set up a route properly for it, which means that we can't show you in the memory profiler what project assets or script is related to. So it's not rooted properly with all the other things in the world. So that's not exciting, as I say, but we can now break that down by memory label as well. So memory labels are an internal thing, but they are human readable. You can look at them and know generally what they mean. And there's an option that we've added on the command line, enable memory profiler call stacks. So if you set this option when you're running your game, or editor, if that's what you're profiling, and then take a memory profiler snapshot, you'll actually get some call stack information, managed call stack information about where the objects come from, which can be really helpful in trying to see where's this thing being loaded from, or can I change something in my code that will stop this unrooted memory from being allocated. There's a couple of other tiny bits, which I'm going to say are like a pinch of spices we're adding. We break down the residency status of the managed memory in your project by whether or not it is resident. Previously, that was all just shown as the same setting. You couldn't tell. And the memory profiler now also includes a UTC timestamp, which might sound like a really silly thing, but if any of you went to the talk about the memory profiler that was given, one of the workflows that they were discussing was to do with looking at matching things up with the between the memory profiler and other tools. And without that timestamp, we were doing this, and we were like, it's really fiddly trying to remember precisely where in my other capture my memory profiler capture comes in. So now in the memory profiler, you can see what the time was when you took the snapshot, which can make it that bit easier to match up data. Coming back over here, and I will demo some of those things, show you where they are. So switch over to Memory Profiler and open my snapshot up. So if you're not aware about where you see residency status, you can see information up here about what's resident on the device, but these subgraphs down here also show you with the kind of lighter colored part, the part that was resident in memory versus the part that wasn't. And now the managed heap utilization also shows that. In my test case, it's nearly all resident, so it's not actually very exciting. But if you look very closely, you can see that there's a tiny little bit of gray, like good use for my spoon, right here, that's not there when I move the mouse off. So that's where you would see residence information, although you can also see some of that in some of the other tables. But the stuff that I was talking about with the unrooted memory, we're going to come in here. We're going to look in all of memory. And then if you come into native and then Unity subsystems, we can see we have some memory that's described as being unrooted. And down inside that, we have some things you can see by different system where that's come from. There are some things which are marked as having no memory label, which is a bug in Unity. And I would go as far as saying that the unrooted memory is also a bug in Unity. So if you're seeing lots of these things in particular areas, it's worth filing issues for them. We do have a process set up now where we are able to run through test cases and file bugs with teams who own the memory internally to make it a lot easier for us to get those fixed. So just last week, or the week before, I filed like 40 issues with different teams, and my inbox caught fire because then every issue comes back to me to say the team's looking at it. But you can drill down into these individual things. You see the address of the allocation, but then in the panel on the right over here, this is where you go to see your managed call stack information. So I have no idea whether or not the thing I'm clicking on here is going to be at all interesting. Okay, there's a thing, this looks like this is a job thing, and this particular session has some analytics. Memory that's been allocated, which we need to fix up, may already be fixed. But if it's something that's triggered by your source code, you'll be able to go, well, if I didn't do that thing, I wouldn't see this managed memory, or if I did that a different way, I wouldn't see this. Yeah. So there's a few more performance-themed improvements that I thought it was worth talking about as well. And these aren't things that my team work on, but other teams at Unity do. And I just wanted to kind of highlight them because I don't think they're anywhere else out on the booths or in other talks. So one of them is the stats window in the editor, which has been updated. And in new versions of the editor, this should now have up-to-date rendering information for URP and other render pipelines, as well as for the built-in render pipeline. And my favorite part of this, but it might be because I'm biased, is that open profiler button at the bottom, because we do know there are some users who are coming in here and they were using this to look at their frame rate and try and make optimizations. So the idea is those users kind of have something to guide them into using the profiling tools. Jobs profiler. So this is a thing that obviously lots of modern devices, pretty much everything, has multiple cores you can run on. Unity has stuff where you can be running jobs and split work across those cores, but it can be tricky in the profiler. You can often get an idea of how much you're using them, but it can be difficult to see why one job is running where it is. Typically, what's happening is that you need to investigate the dependencies of a job and follow those back through. So there's this new experimental jobs profiler. It's a package. You have to add it at the moment. You also have to add it by name, and the instructions are on this discussions thread while it's experimental. But it drops in here in replacement for the normal timeline. You click on a job, and you can see what its dependencies were. We highlight where they all are. This is in quite active development at the moment, so if you try it out, if you've got any feedback, there is this discussion thread. Please come and share it, because we'd love to hear from you. Make sure that we get everything right. What we want to do here is polish it up, make sure it's at least as good as what's in the normal timeline, and then switch them over. So this is just there permanently for everybody. But while we're working on getting feedback, it's just experimental. So please take a look. Adaptive performance was a package when I mentioned it this time last year, and is now a module, so it's built into Unity. It's basically a set of features around adapting what's running in your game based on how your game is performing. So on, for example, low-end Android devices, you might want to turn some systems off. On high-end devices, you turn things on. It can do that based on a few things like just frame rate, but it can also do things based on temperature, where that information is available on devices. Currently, it works on mobile devices and desktop, I think. So you can have it built into games on desktop as well, where you've got big performance differences between different machines. One thing that this was also mentioned in the keynote is that Unity 6.2 brings engine diagnostics, which might not sound super interesting, but from my perspective, there's a very interesting part of it, which is the profiling and performance data that we're adding with that. So in 6.2, there's a minimal amount of data there, but it is there already, collecting data about the frame rate your game's running at and the amount of memory that you're using. We're basically adding to that as we go forwards through the year. So different Unity versions should bring more data. You can go and view this data on dashboards at cloud.unity.com for released projects. And if you've got any feedback about particular things that you want to be able to do with that data, it would be awesome to hear from you. We're obviously looking to do things like being able to slice it by the device type and understand which devices aren't performing so well and where in your game people might be having problems. But any feedback on that, we'd love to hear as well. Another thing that this is bringing to the profiler is some of the extra data that's coming with this. So as we add more data in here, we should be able to surface that to you in the profiler as well. I guess it's finally time to wrap up. What we've been through. So we've been through Project Auditor, what it does, what it analyzes, and loosely how it does some of that, the fact that it's a package and will now be built in. We looked at the improved profiler workflows and what we've changed since I talked about this last year, mostly focused on the capture list, the overview, and being able to change your capture length. And then the main thing in Memory Profiler is those unrooted memory labels and call stacks. And I've added on the end of this, I have one more thing. You might think I'm stealing this from Steve Jobs, but clearly I'm going to show my age. I'm stealing it from Columbo, the 70s detective who used to follow the murderer around in his show and say one more thing and ask them questions all the time. No murders here, but it's another profiler thing. So this is something that we are demoing out on the show floor on the profiler and performance booth at the moment. But it's integration between the profiler and the Unity AI assistant. So I have a capture here where I have a big spike in frame time. I happen to know it's a problem that I've added to show you guys. But you can come into the summary view and ask the assistant, and you can say, well, I type very slowly, why is my game running slowly? And that will then go off to the Unity AI assistant. There are tools that the assistant can use that allow it to query the profiler data. It goes in, it asks about the different samples that are in there, tries to find what's going to be causing the biggest problems. It will actually go and investigate particular scripts, and it will read your code. And here it recommends particular things that should be fixed in this function to do with some order n squared things where I'm doing things in a loop inside a loop, expensive operations. Basically, I threw everything bad into one function, and it's found it. But you can also go and ask about markers. So if you don't know what a marker does, like physics overlap sphere, you can come and ask assistant there, and assistant will then go and give you information. If you're interested in seeing more about that, come see us over on the booth afterwards. We have a proper demo set up, and you can go through some of it there and answer any questions or whatever. So thank you very much.